Hi girls, in this video we are going to explain the different separation techniques. Separation techniques, these are the methods that are used to separate different types of mixtures. We separate mixtures depend on their physical properties. Okay, so for example, filtration, this method can be used to separate a solid from a liquid in a heterogeneous mixture. So if you have a solid insoluble in a liquid, you can use filtration. The apparatus needed: filter funnel, conical flask, and filter paper. When you do filtration, you have filter funnel, filter paper, conical flask, and you put the mixture here. Solid will remain inside the funnel while the liquid part can flow. The liquid that can flow, we call it distillate, while the solid which remain here, we call it residue. So residue is the solid which remain in the filter paper, while the filtrate is the liquid that flow through the filter paper. We have so many examples for filtration: mixture of sand and water, mixture of salt, sugar, and alcohol, mixture of ground coffee beans and brewed coffee, and so on. The second method of separation is decantation. Decantation is a process of pouring off the liquid and leaving the solid behind. So it doesn't need apparatus, it doesn't just need a beaker to collect the filtrate, and you have another beaker which contains the mixture. The solid part of the mixture will remain here while the liquid part can flow down. This method we call it decantation. So the solid will be left behind. Just beakers and glass rod is used to separate muddy river water and the separating mixture of soil and water. Now, another method of separation, we call it sublimation. Sublimation is the direct change of matter from solid to gas on heating. So it's a process of converting solid directly to vapor without converting it into the liquid. The vapor on cooling gives back the solid, and it's called sublimate. So here you are going to heat the mixture. One of them is going to sublime, changing it into vapor. The vapor, you will cool it down, it will change to solid, and then you can collect the solid. We need here conical flask or petri dish, filter funnel, burner, tripod, and cotton plug. Examples of substance that sublime, you should memorize them: ammonium chloride, iodine, naphthalene, camphor, and benzoic acid. You should memorize those examples. Another method of separation is evaporation. Evaporation is converting liquid to vapor at any temperature when you heat the liquid. Here in this method, when you evaporate, the solid solute will be left behind in the evaporating basin and the liquid will evaporate. The apparatus needed: Bunsen burner, tripod, evaporating dish, and gauze. So it's very simple. You just need to heat the mixture. Water will evaporate and the soluble solid is going to precipitate here. And we call this method evaporation. So we need here tripod and Bunsen burner and evaporating basin. These are the apparatus required. Examples: sodium chloride crystals and copper sulfate crystals from copper sulfate solution. Describe, using a label diagram and the examples, crystallization as a separation technique. Crystallization is very similar to evaporation. The only difference is you are going to obtain a solid which has some solvent, some liquid inside it. When you cool it down, the solid will separate as crystals. So this technique is used for obtaining a solid compound in pure and geometrical form. The impure sample of solid substance is dissolved in a solvent to make a saturated solution at a high temperature. When such solution is cooled, the substance appears in the form of crystals. The solution left behind is called mother liquor or mother liquor, which consists of all impurities. The crystals thus obtained can be separated with the help of a spatula. The apparatus required: beaker, spatula, Bunsen burner, and evaporating dish. Let me explain it to you in more details. We can use a crystallization to separate impurities from a liquid. So you will get an evaporating basin, and you are going to carry out the evaporation process by heating the mixture. What will happen? As you are heating, the solvent is going to, the water or solvent is going to evaporate, and you will be left out with concentrated solution. And what about impurities? Impurities, if you have sugar solution and it has impurities of sand or some tea or coffee, so here you are going to heat until you get very concentrated solution of sugar. Other impurities will be left here, will not evaporate or condense. If you leave it to cool down, the crystals of the liquid will separate and the impurities will stick to the wall of the container, so it's very simple to remove them by a spatula. Next method, describe using label diagram. A magnet. How to use a magnet as a separation technique. You know that magnetism is a form of separating mixture which involve using a magnet to attract another magnetic object away from the substance it's in. Like you can separate iron from other metals that might be mixed with it using a magnet. This method can be used in factories. Materials are put in the conveyor belt that is spun, means it turns very fast, by magnetic wheels. As the object moves upside down, the non-magnetic object fall off and the magnetic ones stay on. I will give you another example. If you have a magnet and you need to separate, if you have a magnet, okay, and you have a mixture of iron with other metals. So you are going to approach the magnet from the mixture of iron and other metals or other substance. Once you approach the magnet closer to the metal, to iron, it's going to attract iron, stay on it. Well, what happened to other objects or non-magnetic material? They will fall down. In this way, you separated the mixture. So the examples that can be given here: separating iron from mixture of iron and sulfur, separating iron nails from glass chippings, separating iron paper clips from brass ones. The next method of separation is using separating funnel as a separation technique. Separating funnel is used for the separation of components of a mixture between two immiscible liquid phases. Means they are two liquids that are not soluble in each other or not mixed together. And this happens because they have different densities. Separation is based on the differences in densities of liquid. The liquid having more density form the lower layer, so it will be at the bottom, while the liquid which has less density or lighter will form the upper layer. You know the shape of the apparatus, the separating funnel. Can be used to separate oil from water, because oil is going to float over the surface of water because it has less density, and the water will be at the bottom forming the lower layer. So water, which is more dense, will form the lower layer, while oil, which is less dense, form the upper layer. So once you open the tap here, you are going to separate water first, and then you turn it off, switch it off, so oil will remain here on the separating funnel. So some examples here: separating oil and water, because oil is less dense, will float over the surface of water. Also, we can separate mixture of kerosene and oil, kerosene oil and water. Kerosene also is less dense than water and is going to float over its surface. The next method of separation, we call it centrifugation. What is centrifugation? Centrifugation is a method that we can use it to separate insoluble material from liquid where normal filtration doesn't work. If the filtration doesn't work, means if you have an insoluble solid in a liquid, you can separate them by centrifugation. This method works just you put the mixture in a special test tube, and then you will put it in a special apparatus. It's going to spin very quickly at very high speed, spin at very high speed. On this way, they are going to be separated. Lighter substance will be left near the top. So the parts which has less density will be on the top, and the heavier particles will stay in the center. We call this method centrifugation. So I just need a centrifuge, which is a big apparatus, and centrifuge tubes. Also, it's used in diagnostic laboratories for blood and urine. If you make blood analysis or urine analysis, you often use a centrifuge. Also, it can be used at home to separate butter from cream. Butter and cream have different density, but filtration doesn't work to separate them. So I can use centrifugation to separate them. Next method of separation is simple distillation. Simple distillation is used to separate components of a mixture which has two miscible liquids or soluble salts, having a boiling point difference by at least 10 to 20 degrees Celsius. Liquid having lower boiling point will distill first because it's boiled first, leaving another liquid behind. For distillation process, liquid mixture is taken in the distillation flask, fitted with thermometer and condenser. To avoid pumping the liquid, few glass beads are used. Distillation flask is then heated. The liquid having low boiling point will boil first, and its vapor will get condensed into liquid. This condensed liquid is called distillate, which is collected in the receiver, while the liquid having higher boiling point is left behind in the distillation flask. In this regard, we need Bunsen burner, retort stand, tripod, hose, round bottom flask, conical flask, thermometer, condenser, glass beads, and beaker. Like separating pure water from a solution of sodium chloride or pure water from acetone. The next method is fractional distillation. Let me first summarize quickly the simple distillation. This is a simple distillation apparatus. We put here salt water, Bunsen burner, retort stand. This is a retort stand and clamp, thermometer, condenser, and conical flask. And this one is round bottom flask. We put some glass beads inside here. When you boil salt solution with water, at 100 degrees Celsius, water will evaporate. The vapor will pass through the condenser, and it's going to condense or cool down by the cold water in. It will be condensed into condensed water in the receiving flask. So you are going to collect distilled water here or clear water, while the salt will be left here in the round bottom flask. Now let's go to the next point, fractional distillation. Fractional distillation is a method used to separate two or more miscible liquids that have close boiling point. Remember, simple distillation, it should be 10 to 20 degrees Celsius difference. Here we need the boiling points to be very close, and it's used to separate two or more liquids. It works in the same way as simple distillation. So the solution is heated until it boils. Liquid with lowest boiling point boils first and becomes a vapor. The vapor is cooled in the condenser until the temperature falls below the boiling point, when it condenses back into liquid, which is collected in the container. The collected liquid, we call it distillate, which has been distilled. The condenser has cold water running through the jacket around the outside to keep the temperature below the boiling point of the vapor. After the liquid with the lowest boiling point has been collected, the temperature of the remaining mixture will rise to a new temperature. Suppose you have a mixture of alcohol and water. So alcohol will boil first, condense, and you collect it, and then raise the temperature until 100 degrees Celsius in order for the next liquid to boil, and then it will be collected. The process will continue until you separate all the liquids you have in the mixture. But remember that we do have here a fractionating column is needed. Why? Provide large surface area for condensation, which means different pure fractions are separated. You can just write in the exam, if you are asked why we need fractionating column, we need it to obtain pure fraction or pure liquid. Okay? The apparatus needed: Bunsen burner, retort stand, tripod, gauze, round bottom flask, conical flask, fractionating column, thermometer, condenser, glass beads, and beaker. This method can be used to separate mixture of water and ethanol or oil components. The last method of separation, we call it chromatography. Chromatography is a method used to separate the different components in a liquid mixture, but it usually famous with separating of dyes or ink or paints, and this is how they got their name, chromatography. It involves the sample being dissolved in a particular solvent. So if you have ink or paint or color and you dissolve it in a solvent like water, we call this mobile phase. Mobile phase may be a gas or a liquid. The mobile phase is then passed through another phase. We call it stationary phase. What is the stationary phase? Stationary phase, it might be a solid packed in a glass plate or a chromatography paper. And you have seen it in the lab that the chromatography paper where the mobile phase move on. The various components of the mixture travel at different speeds. So if you have 2 different or 3 different colors, they are going to travel on the paper at different speeds. So they are going to separate at different distances. This causes them to move at different rates through the paper. Paper chromatography uses paper at the stationary phase, and a liquid solvent is the mobile phase. In paper chromatography, the sample is placed on the spot, drawn on a line, drawn in pencil, not in ink because the ink can dissolve in the solvent, the baseline on the paper, and the paper is carefully put into the solvent. The solvent rises up the paper due to capillary action till it reaches the solvent front. The components of a mixture rise up at different rates and thus are separated from one another. This separation produces a chromatogram. Let me explain it to it in more details. So looking carefully here, this is the chromatography paper. Here is the beaker that we put the paper in. The paper is the stationary phase, this paper. The solvent that we put here is the mobile phase. If you put you are going to draw a line on pencil on the paper, like I will draw a line here. And you will put the spot, the ink spot that you need to separate on the line. The ink spots are going to spread because they dissolve in the filter paper, in the solvent at different rates, so they are going to travel on the chromatography paper at different speeds. And they are going to separate into their components. Suppose this is dye 1 and this is dye 2, or A and B. Dye A consists of 2 colors, while B consists of also 2 colors. Both of them have blue, but dye A has yellow and the dye B has green. And then you need to be able to measure the RF value of your product chromatogram. How to measure the RF value of a separate spot? Suppose you are asked to measure the RF value of the blue color. How can I measure it? You will measure the distance moved by the spot. The spot has moved from this point to this point. So you will measure this distance, it's 4 centimeters. So I will write 4 over the distance moved by the solvent. Here is the solvent. Solvent goes up to this point that we call it solvent front. Here it moves 10 centimeters. So you will divide 4 over 10 equal 0.4, and it doesn't have a unit. If you are asked to measure the RF value of another spot, so you do need to measure the distance moved by the other spot for the yellow one or for the green one in the same way. Now let's discuss the uses of chromatography. First, distinguish between pure and impure substance. Pure substance is going to give only one spot because it's pure, it has one substance only, while the impure will produce 2 or more spots. Paper chromatography can be also used to identify substance by comparing their RF value. When you compare the RF value, so you can compare and identify the substances present in the mixture. If you have 2 different mixtures give a spot which had the same RF value, means they do have the same substance. Then let's focus on the RF value. You should be able to write the equation, and you should know its use, which is to compare range of reference substances. You are going to compare the identity of different substances by measuring their RF value. The apparatus needed to measure the RF value is the chromatography paper, beaker, lead, and pencil. We have some examples here: separating colors in a dye, separating pigments from natural colors. as the experiment we have done in the lab by separating pigments from chlorophyll. Now let's start answering some questions. Here, when would you use filtration to separate a mixture? We use filtration if I have what? If you have a solid and the solid should be insoluble in a liquid. In this case, you use filtration. Next question. Describe a procedure you could use to separate a mixture of sand and table salt. If you have a mixture of sand and table salt, first you should add water in order to dissolve the salt. Secondly, stir with a glass rod. Then you need to evaporate water, or before evaporation, what do we need to do? Yes, we need to make filtration in order to separate sand, and after that you will do evaporation to separate salt. Question 3. What is the goal of distillation? Distillation is used to separate components of a solution. Okay? How this goal is accomplished? It involves two main processes you should memorize. The first process is evaporation, and the second process is condensation. We have here some solved problems. Question 1 here. Which of the following separation technique can be used to separate insoluble solid from a liquid? As it is insoluble, so the only method is filtration. Question 2. What is the name of the above separation technique? This separation technique, we call it decantation. Next question. What are the physical states of substance R and T? It's very clear that R is liquid, right? And the T is solid. So we will choose here R is a liquid while T is solid. Question 4. Diagram below represent what? Separating funnel. So this is separating funnel. Why? Where oil is what than water? Lighter, because it's on the top. That's why it floats. So oil is lighter than water. That is why it can be separated from mixture of oil and water at the end. Salt is soluble in water, but sand is insoluble in water. This difference allows a mixture of salt and sand to be separated using this apparatus. Answer questions A to C. It's very simple. As we have just said, if you have a mixture of sand and salt, what do you need to do? First, dissolve salt in water and use a glass rod in order to make sure that the salt dissolved completely. Then make a filtration, filter out the sand, and the salt solution will be the filtrate. And then get the filtrate and put it in the evaporating basin and allow it to evaporate. Allow water to evaporate, the salt will be left behind. Now let's complete those sentences. In step 1, the mixture of salt and sand is placed in beaker containing water and stirred with glass rod. In step 2, mixture from step 1 is poured through, filter funnel, into a conical flask. In step 3, the liquid is transferred to a basin to allow water to evaporate or to be removed. What needs to be placed in A before mixture in step 1 is poured? Here, this is filter funnel. You can see that it needs filter paper. So I should put filter paper before you carry out the filtration process. What is the solid removed in step 2? In step 2, sand will be left here. So this is a solid, right? Sand will be left in the filter paper. So the solid which remains is sand. List the name of the process used in this separation. What are the processes used? Here, first process was filtration and the second process was evaporation. So the answer is filtration and evaporation. Looking at this question, you can see it's a very important one and has 10 marks. So you should study this process very carefully. Consider the following separation technique to answer questions A to C. Name the method of separation represented in the figure above. This method is fractional distillation. And if you write just a distillation or simple distillation, it will not be accepted and you will earn a 0 point. First, before we start, let's describe the process and label the apparatus. C is thermometer. D is a condenser. Here, F and E, it's cold water in and out. So for F is cold water in, and for E is cold water out. G is the distillate because it is the pure liquid that you are collecting, and we call it distillate. H is a conical flask. Conical N. A is a round bottom flask. Here, this is a Bunsen burner. And B is a fractionating column. We explained before the use of fractionating column help us to obtain a pure liquid because it increases the surface area. So the question here is to identify the change of state that happens at A and D. If you look at A, what is the change happening here? We are heating, so it's evaporation. And what is the change happening at D? Through the condenser, it's condensation. Evaporation and condensation. Label H and C. What is H? Is a conical flask. And what is C? Where is C? Yeah, C is a thermometer. Right? Label H and C. We are done with this question. So now let's move to the next question. Here in Learning Objective 6, you should learn about the SI unit. You all know that the SI unit for length is meter, for mass is kilogram, for time is second, and for temperature is Kelvin. And then describe the role of prefixes. It's very important because it adds a value to the unit you are measuring. It gives you the magnitude of the measurement. Prefixes are explained here. Mega, 10 power 6, and kilo, K, 10 power 3, deci, D, 10 power negative 1, centi, C, 10 power negative 2, milli, M, 10 power negative 3, micro, and a micro, 10 power negative 6, nano, N, 10 power negative 9, pico, P, 10 power negative 12. These are the prefixes that you should know. And then you need to learn how to convert temperature from Celsius to Kelvin and the opposite. So K equals Celsius plus 273, or you can say that C C equal Kelvin minus 273. Depend on the quantity you are asked to get. Write the name and symbol of the SI unit used for mass, length, volume, and temperature. For mass is kilogram, the symbol is kg, length is meter, m, volume cubic meter, m cube, temperature is Kelvin. Next question, write the symbol and the meaning of each of the prefix below. Milli, nano, deci, centi. Milli, m, 10 power negative 3, nano, n, 10 power negative 9, deci, d, 10 power negative 1, centi, c, 10 power negative 2. Remember that those units should be written in a small letter, not in a capital letter. Here, this question is asking you to arrange the following units in order of from the largest to the smallest: meter cube, ml, cl, microliter, liter, deciliter, and so on. The biggest unit here is a meter cube, because meter cube equal 10 power 3 liters. So I will start with meter cube. And then liter, deciliter here are very simple because they are just mentioning the negative values. Deciliter, 10 power negative 1. And then centi, 10 power negative 2. Milli, 10 power negative 3. Micro, 10 power negative 4. So here we are arranging them from the big unit to the small unit. Next question. Calculate surgical instrument may be sterilized by heating at 170 Celsius for 1.5 hours. Convert Celsius to Kelvin. Very simple. Okay, Celsius, Kelvin equal Celsius plus 273. So the temperature in Celsius, the temperature in Celsius here was 170. So 170 plus 273 equal 443. You should memorize this number. And don't forget to write the final unit, Kelvin. Next question, order those units from the smallest to the largest. Micrometer, kilometer, millimeter, meter, nanometer, decimeter, picometer. And then give each measurement in terms of meter. So you write the value of each: kilometer 10 power 3, centimeter 10 power negative 2, micrometer 10 power negative 6, decimeter 10 power negative 1, millimeter 10 power negative 3, nanometer 10 power negative 9, and picometer 10 power negative 12. Picometer 10 power negative 12. State the relationship between degrees Celsius and Kelvin. Degree Celsius, as you know, equal Kelvin degree minus 273. And then you have a question, melting point of silver, 962 Celsius, express the temperature in Kelvin. So Kelvin equals Celsius degree plus 273. 962 plus 273, the answer will be 1235 Kelvin. Which is the SI unit of time? SI unit of time is second. The prefix pico means 10 power negative 12. You should memorize those. What is the temperature of 5 Kelvin in Celsius? So to change Kelvin to Celsius, you need to subtract from 273. So Celsius equal Kelvin degree minus 273. So the result, of course, will be less than 273. You don't need to make the calculation, just look at the choices. So the result first, it should be in negative. So you are going to discard those positive results. So your answer should be A or B. Of course, it will never be minus 273 because I'm subtracting 5 from 273. So A will be the correct answer, the only possible answer. Write the correct SI unit for each of the following. Mass, kilogram, length is meter, temperature is Kelvin. Now we have reached to the last question. A student recorded temperature of a chemical reaction to be 85 degrees. At the end of the reaction, the temperature dropped to 60 degrees. Convert the temperature into Kelvin. So very simple, you are asked to convert both temperatures into Kelvin. First, write the formula. Kelvin temperature equals Celsius plus 273. There are 2 marks for that. Temperature in Kelvin is a capital letter. Temperature in Celsius should be written in a small letter. And then you will get the temperature in Kelvin equal 85. The first reading, 85 plus 273 equal 358 Kelvin. And for the second one, 60 plus 273 equal 333 Kelvin. Now we are done with all questions in the revision guide. I hope you the best of luck in tomorrow's exam, inshallah.